Hello there, and welcome to another problem-solving session with Special Maths Academy. So we'll be looking at problem 4 of the second round. They just concluded Nigerian Mathematics Olympiad. And actually, later we saw that this problem 4 was actually taken from the AIME as the American Invitational Mathematics Exam. I think 2011 problem line 9. But all the same, we'll just look into this problem and try and solve it. So it says let x1, x2 up to x6 be non-negative real numbers such that the sum is equal to 1. And then we have that x1, x3, x5. So the x's with the odd subs, the product of the x's with the odd subs plus the product of the x's with the even subs is greater than or equals to 1 over 540. So let p and q be relatively prime integers such that p over q is the maximum possible value of this expression here. So we're told to find p plus q. Okay. So one of the important things we can take note of is that so x1 plus x2 plus x is equals to 1, and since these are all non-negative real numbers, so xi greater than or equals to 0. So this implies that each of these numbers, x1 is less than or equals to 1. Okay, so a very weak bound for this will be that x1, x2, x3 is less than or equals to x1 into 1 times 1. Okay, x2, x3, x4. So we're just applying this for each of them. So let me just put xi. So each of the xi is less than or equals to 1. So a weak bound we can get quickly is this, less than x2 into 1 times 1, and so on and so forth, up to x6, x1, x2, less than or equals to. So we can quickly get that this is less than or equals to 1. Okay? Yeah. But here now we see that equality only holds when each of these numbers here is equal to 1, which can't hold, which it's very, very impossible because we have that the sum is equal to 1 and none of them is negative. So yeah, that can't work. So but this is a very weak bound for this some of these expressions. So this is less than or equal to 1. So let's move on and just see what we can get from this. Okay, so one of the ways we can look at this is looking at this problem. The first thing that came to my mind was that we see that there's a kind of how I put it, uniformity in this expression. So it's almost symmetric. So for instance, we look at x1. So which terms does x1 associate with in this sum? So for instance, x1 associates with x2. So let me just write it here. And then which terms it associates with. So associates with means which terms it shares a product with in this sum. Okay, so we have x2 is in this set. We have x3 is in this set. Okay, where else does x1 appear? We have x5 and x6. So let me just erase this. And x6, and I think that is going to be all. Okay, so x1 doesn't appear where x4 is, and so we see that we can do a similar thing for each of those brackets. So we'll say x1 and x4 are not friends. I mean, we can see a similar pattern. x2 and x5 are not friends because there's no product that contains x2 and x5. You can check that. And we see that x3 and x6 are not friends. So what does this give us? This just hints at us, it's screaming at us to just check out what this product will look like. So x1 plus x4. So we see that when we put x1 and x4 in a bracket and we want to multiply it out, what comes out is that x1 and x4 are never multiplied together, okay? So what this is just screaming at us is to multiply this out and see what we get. Okay, so don't forget where I got the hunch from. So the not friends list, so I'll just put that. And I know it's a very funny thing. Mathematicians always come up with very, very funny, ways of expressing their ideas. So the not friends list. So I have x1 and x4. So we're just adding 3 to the sub. So x2 and x5 and x3 and x6. Okay. And so when we multiply this out, what comes out? We see that we have x1. So let's just multiply the first two brackets first. So x1 times x2 plus x1 times x5. Okay, plus x2 times x4 plus x4 times x5 so into x3 plus x6. Okay, so but first of all, before multiplying this bracket, we have 2 terms here, 2 terms here, and 2 terms here. So we're expecting 8 terms when we multiply this bracket out. But what do we have here? We have only 6 terms here. Okay, so that's just one thing you should have in mind. So it means we'll need to subtract some things from this multiplication to even things out here. Okay, so just scroll down a little bit. Okay, so then we multiply this out some more. So let me just change my color because I want things to look more interesting here. Okay, so x1 times x1 x2 times x3. So I have x1 x2 x3. So the first term shows x1 x5 times x3. So I'll write the terms that are not showing. I'll write them in green. So this term is not here. So plus x1 x5 x3. So let me just put it let us put it in ascending order. So that's the product of this term and this term. Okay, so that does not show there. And then I go back to this. X2 x4 times x3. So yeah, that shows. So it's going to be x2 x3 x4. Okay, and then we have x4 x5 times x3. That also shows. So x4. So I'm just put it in a way that it aligns with what we have up there. Okay, so we're done with the x3. So now we have x1 x2 times x6. So I'll just put it in a way that it appears here. So this has shown. So this will be plus x6 x1 x2. So this is this here. Okay, and then x1 x5 times x6. So this is going to be plus x6. So plus x5 times x6 times x1. Okay, and that is this here. X2 x4 times x6. So this doesn't show, so write it in green. So this is x2 x4 times x6. Okay, so now we suspect that every other thing will show because we've gotten 2 terms that don't show, and we're expecting a total of 8 terms from this multiplication, and we have 6 terms that want to appear here that we most likely have a strong hunch that all will appear. Okay, So then we have x4, x5 times x6, and that certainly shows. So x4, x5 times x6. Okay. Now you don't need to do this on your solution script in the exam hall, but we're just doing it to check that our hunch is correct. And what's our hunch? Oh, I haven't told you guys the hunch. So the hunch is that so I'll just write it up here so I can erase this. So I'll just call this expression. I'll call this expression M. So the hunch is that x1 plus x4, x2 plus x5, and x3 plus x6 is equal to M plus the odd subs plus the even subs. Okay, so that's our hunch. So now we can erase all this. So don't forget what I said, what M is. So this whole here. So we say let it be M, okay? So what are some of the things we can do? Okay. So definitely we'll want to scroll back up and see what we can do. So now we haven't applied the sum yet. That's we haven't applied the fact that x1 plus x2 plus x3 plus x4 plus x5 plus x6 equals to 1. We haven't applied that yet, so we need to find a way to apply that. Okay. So let's apply that. And we're going to apply it in a way, because we know that addition is something that can be done in any order. So we'll just do it this way. So x1 plus x4 plus x2 plus x5 plus x3 plus x6 all over 3. So now at this juncture, we're going to apply what we call the AMGM inequality. So it just says that the arithmetic mean is always greater than or equal to the geometric mean. Okay, so that's something you should be familiar with in the Olympiad. And so we have this is equal to, this is greater than or equals to the cube root of x1 plus x4 into x2 plus x5 into, so I'll just shift a little bit to the left again, to the cube root into x3 plus x6. But don't forget that we already know that this sum is 1 over is 1. So it means what we have on the left hand side will be 1 over 3, greater than or equals to the cube root of. So don't forget what we said. This is M plus, so from what we had here, M plus x1, x3, x5 plus x2, x4, x6. Now, because we're dealing with basically positive real numbers or non-negative real numbers, so we can cube both sides. And so we can square both sides, we can cube both sides, we can do all those things because we're dealing with the friendly numbers, which I call the positive real numbers, or the non-negative real numbers, because I mean 0 doesn't really make much difference except you're dividing. Okay, so cubing both sides, we have 1 over 27 is greater than or equals to M plus x1, x3, x5 plus x2, x4, x6 Now don't forget, we have that this is greater than or equals to 1 over 540. So this is greater than or equals to 1 over 540. So this together is greater than or equals to m plus 1 over 540. Okay, so we can get that from the translation, from the law of transitivity in inequality. So I have 1 over 27 is greater than or equals to m plus 1 over 540. Okay, and so this becomes so this is just going to be 20 over 540 minus 1 over 540 greater than or equals to m, which implies that, so this is just going to be 19 over 540 greater than or equals to m. So we see that this is already in the lowest term. So our P and Q is P over Q is equals to 19 over 540. And so P plus Q is going to be 559. So this is the answer. So this was an interesting problem in that we had to see where the factorization had to come in and had to help all that. So that'll be all. Don't forget to like, share this video, subscribe if you haven't subscribed. I mean, what are you waiting for? And yeah, see you guys in the next video. Goodbye, guys. Yeah, so just a little addendum to the problem 4. Initially, we showed a weaker bound for this guy here we called m. We showed that m was less than or equal to 1, and we showed that this bound is so weak that in fact it can't achieve 1. And then we later got that m is less than or equal to 19 over 540. But then we need to show that here it can achieve this value. So a good way to look at that is, okay, so we look at the inequalities we applied. And AMGM inequality, for equality to hold, we have that the terms we're applying the AMGM equality to must be equal. So that's why we have this here. All this must be equal and hence equal to 1 over 3. And then we have this inequality we applied that was given in the question already. And so for equality to hold, then this value here must be equal to 1 over 540. Okay. So a good way to look at this, a good way to get this inequality, we can find a way to solve some equations. For instance, we can maybe fix x1 to be equal to 0, and we can fix x3 to be equal to x5. Okay, and so if x1 is equal to 0, and then we can replace x4 with 1 over 3 minus x1. We can replace x2 with 1 over 3 minus x5, and so on and so forth. We can replace x6 with 1 over 3 minus x1. No, rather x3, yeah. So we can replace x6. So this is going to be x4, x2, and x6. Okay. And what do we have? This inequality here becomes x1, x3, x5 plus, so we have 1 over 3 minus x5 into 1 over 3 minus x1 into 1 over 3 minus x3 equals to 1 over 540. And so we can expand quickly. And we see that in fact, when we expand, this guy here will cancel out with the product of this, and this. So, but yeah, just one of the things we can do. So I won't waste much of our time. So we can expand quickly and simplify, and we get 20 minus 60 into the sum. And plus 180 into the sum of the product. Taking two at a time. So yeah, this. Yeah, so I have that this is equal to 1. And so we're just trying to get a case of equality. And so when we do this, we can now fix what I said here. So we can fix let this be equal to y and let this be equal to 0. So what we have here, we have 19. Sorry, it should be 19. So when this comes here, 19 minus 120y, because we have x, this 2 here will come y plus y 2y, and plus 180 into y squared equals to 0. So we can get that y is equal to, so when we apply this, we have 120 plus minus root b squared. So 120 squared minus 4ac, and this is 720. So to do that, I already used a calculator to do that, because I don't want this video to be longer than necessary. All over 2a, which is 360. And when this is simplified, this gives us 120 plus minus 12 root 5. Yeah. All over 360. And this is equal to 10. So I'll just put it so y is equal to 10 plus minus root 5 all over 30. But we see that if it's 10 plus root 5, 10 plus root 5 is already greater than 1 over 3, which is already 10 over 30, okay? So it means it's going to be 10 minus root 5, so just remove this plus. So now it means if we fix this value, so if we fix x3 equals to x5 equals to 10 minus root 5 over 30, and x1 equals to 0. So what does this imply? It implies that x4, which is equals to 1 over 3 minus x1, so x4 is going to be equals to 1 over 3. x2 is going to be equals to root 5 over 30, so x2 is going to be equal to x6, so we're going to be equal to root 5 over 30. And we see that when we fix this to our m, we get that this value is achievable. So this 19 over 540 is achievable, okay? And so we see that m is less than or equal to this, so it can achieve the 19 over 540, but it cannot go higher than it. So this is just one of the example of the values that can achieve this. Okay, so that'll be all for this video. See you in the next video. Goodbye, guys.